Okay, I'm the second guy after lunch, which means y'all are going to start falling asleep. I apologize in advance. My name's Alan Brown, and representing the work that Mr. Kevin Gordon, Odyssey, and myself and a few others did over this last year, trying to make a flight, RTEMS OSAL, with the Runtime Loader support. You probably heard Alan Cudmore and some others talk about this morning. Well, we had to go ahead and do it for a flight project, and so here we are to give you a quick snapshot of it. Yay, it works. So Odyssey's been around since 2003. We're primarily located in Houston. We got folks in Denver and Austin. We're growing all the time. We do GNC flight software, trajectories, simulation, lots of stuff, cool stuff. A lot of our areas are supporting NASA and for multipurpose crew vehicle. We're doing a lot of work with commercial crew, commercial resupply, visiting vehicle. I'm going to ask some people to eventually cut down these charts because I can't talk about all the cool things that we're doing. But it's not just the engineering side. We've got folks doing ops, and we're doing commercial work on satellites as well. So a pretty interesting bag. A lot of the areas that we support CFS on, we've been supporting NASA for a number of years. And it's nice to hear that some of the things that we've been doing are going to come out open source here soon. But our current roles are for the Deep Space Gateway, moon missions, other things, of which I'm not even all aware, so I couldn't put everything on the chart. We supported some of the Class A certs. We looked into new platforms. Years ago, before I came along, some other folks at Odyssey did work on voting architecture, distributed CFS integration. We built apps for CI and TO. On the commercial side, we do a lot of integrated sim and flight software. We're doing some work on a couple of satellites and the Orion backup flight system. We're doing internal research and development for a number of years on not only integrating the simulations, but we've got a pilot mock-up, human-in-the-loop, that's got displays, vehicle, sims, and core flight software all integrated. We looked into IDEs, UI, data management, so a lot of the pain points, we've bumped into those too, and we spent some time and effort on it, and a lot of those paid off for different customers over the years. Currently, we're capable and are doing now full stack development, all the way from the BSP and custom drivers up through new CFS apps. And some of the apps that we've done for others and are doing now are squarely in GNC and command and data handling. We're working ground dev and test right now, and we've got some folks asking us for a little bit of operational support here and there. And another thing that's been a little surprising that's coming along here is that for multiple customers, we've had folks ask us for some training consulting, because CFS is awesome, but it's a rich ecosystem. But to put that ecosystem to work, to pull your schedule to the left, you kind of want to go ask somebody who's bothered to spend time plowing through it rather than plow through it on your own. And so that can actually be an interesting time saver for projects, and that's been kind of nice. We've got a lot of flight software development going right now for government commercial apps, and so we're growing, and that's CFS and custom solutions both. All right, so the OSAL, one of our customers that we're working right now has got a space mission, and it's laboratory atmospheric space physics at University of Colorado Boulder, right down here. We're helping them develop their flight software stack, and that's a multi-year deep space mission, and that's all I can say about it, but it's a very cool mission. Technically, it's a UT 700 Leon 3. It's a 32-bit Spark 8 processor. We're using the current release 650A. It's a unicore. We don't need to do SMP or anything like that. But we're going with the current release application set. The real objective is to minimize the amount of changes we have to make to NASA supplied code, because that's additional extra effort on our part. But that does mean we got a lot of custom stuff to do, which is not only the new CFS apps, but we also have to work on a new BSP and PSP for the custom board. So we come around to, that's the top and the bottom layers, well, the thing in the middle is the OSAL that makes it all work. And so our customer wanted to go with RTEMS, and they really liked the idea of the Runtime Linker that was introduced in RTEMS 4.11. And so the OSAL that is currently released supports RTEMS 4.10, which doesn't have the RTL. Alan Cudmore started taking a crack at the RTL a while ago, and our customer asked us to see if we can get in and pull this together for them, because their schedule was going to be drastically to the left. And so that's what we went ahead and did. We built an OSAL out. For this mission, the thing that was driving them is they really wanted the ability to load and unload apps and to load libraries. And they needed a flight quality OSAL for the RTEMS RTL. And so not only did we do that, but we went in and just fixed up the OSAL in a lot of areas for functionality and robustness. And we want to give this back to the CFS community and the RTEMS community so that more people can make use of this OSAL. And we found a few things, and we're actually feeding back to both communities. And let's see, for the summary, we've done a lot of functional improvements. I'm not going to read every one of these because we're going to go through them a little bit. Done a lot of functional improvements, some quality improvements, improvements on testing, and we learned a few lessons when it comes to loading modules. This isn't Linux. It's got its own different behavior, but it also makes you think that if you do have loadable modules, there's a lot of gotchas. Unless you've actually started practicing how you want to load up and design and develop your CFS stack, you get yourself in a little bit of trouble. One of the fun things that we found is that with RTEMS, if you want a math library, it's in your kernel, but it's statically linked, so you have to expose your symbols. Well, that restricts your options after your initial load. If you're loading it into MRAM and you've got one load and it's going to be real hard to change after that, do you really want to put libin down in your kernel? Now we've got the option, since we can load things, we might could put libim into a CFS library, and then we can more easily update the library rather than updating the RTEMS kernel. So I think having the runtime loader really expands your options for spaceflight maintenance. Okay, so we implemented this runtime loader, also called Runtime Linker. The words have changed over the years. I'm not sure which one is the current official, but it does the same thing. It's where you can load and unload or replace CFS apps using the elf.o files at runtime. We can also, with this OSAL, dump the full symbol table. That's the RTEMS symbols, as well as all the module entry points. So if we're missing anything, or if we have any question about what we're running with, we can run that down with the OSAL functionality and look at all the symbols. It also helps us figure out when we got a bad load. If you load something up that's missing a symbol, what do you do? And we'll talk about that in a sec. We updated the API to support RTEMS 4.11.1, which is where we're currently aiming at, and where we're going next, which is, as I was writing, it was 4.12, but it's 5.0, and for the next official release. One thing that we found that was a surprise is that RTEMS has a 4-character task name limit. Surprise to us, coming from the CFS world, but what it means is that if you use CFE out of the box, you're going to see a bunch of tasks labeled CFE, 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 time, which task is which. And so we actually put in a mapping functionality to move from the CFE names that were longer and convenient that way to a shorter, readable set of 4-character RTEMS names. If you don't want it, you can take it out, but we thought it was pretty useful for folks who just wanted to take the two out of the box. So what about unresolved symbols? So RTL allows this because you might, with RTEMS, not using CFS, you might want to load something and load something else afterwards and have those modules play together. But from the CFS world, it was a little dicey, and so we wanted to do a conservative stance. We didn't really want to have undefined symbols. And so because we can control the module load order with CFE, we decided that we would have this OSAL automatically unload a module if it contained any unresolved or missing symbol after you did your load. So we can guarantee that if we load it, everything is there, and we're not going to run across some horrible situation on flight. We also had a big discussion on the CFS users group, the mailing list earlier this year about what do you do if you change a file that's mapped in with a loader, and it's operating system dependent. And what we did is we confirmed that with RTEMS and the RTL, that you can change the file in the file system all you want, and there's no effect on the loaded memory image. Now, this is not true for all the operating systems. Your mileage may vary, but we know that this works. Let's see, for the quality improvements, we did a lot of extra work on making sure the error detection, value checking, checking for a couple of off-nominal cases, found them and plugged those holes, ARG checks, things like that. And we did a fair bit of work on the take and give internal mutexes for the global tables, just to make sure that we're trying to avoid as many race conditions and make it multi-thread safe. I am not the expert on this, but we got smart folks like Kevin Gordon and others at Odyssey, and I think this has gotten pretty good. In order to do that, what we do is we differentiate between a failure and a timeout, but we look through all the calling code to make sure that those values weren't being, without no assumptions were being made at the call sites. And so I think we're pretty safe on doing that. Our concern was that we would have a deadlock if we didn't use a timeout. And now I know there's different philosophies of failure handling. What happens if a task takes a mutex and dies? What do you do? Or what happens if something locks up? What do you do? Well, the obvious answer is reboot your board. But we wanted to not only be able to do that, we want to give ourselves a few options to detect the problem. So we've got that capability in there, and it's configurable. You can turn that off if you want to. We placed some unsafe string ops and added a lot of extra debug output. That's pretty helpful. Let's see where we're at. We've got i386 BSP in there, and we've got it's a two-set link process, so you get the symbol table for the kernel and all the modules in there. We've got the BSP start file, and so we run it in QEMU 386. And the tasking example and the OSAL functional test, we call them the black box tests. Those all run and pass. We had a Spark RTEMS Leon 3 BSP, sort of a generic Leon 3 BSP. Again, that's working great. And we tested that in QEMU, and we've also tested that one on our UT700 hardware. Some of the functional improvements that we did is that we went ahead and changed the floating point handling. Is that all the tasks in CFE have floating point enabled. So we went ahead and made sure our OSAL tests did that too, just to keep it consistent and reduce the amount of tests that we had to run. But that's a minor change. For the loader, we actually added quite a bit of load, unload, function calls, shared resource access, corner cases, for memory resources, repeated load and unload. We kind of put it through the ringer and found some interesting results. We added some tests that were missing to the OSAL, the shell output to file, and some of the file function tests for copy, move, remove file system, things like that. So just plugging some stuff there. Unit test, yay, we have RTEMS support. Maybe other people have done it too, but we went ahead and did it. And that's helped a lot. We're working on the unit test right now, and so we'll probably be making a few more minor changes. But I think things are coming together pretty well. So currently we're on the RTEMS 4.11.1 open source tool chain. That's for the Spark and the i386. And we got our Flight BSP, and we've tested that both in hardware and QEMU for our Flight BSP, which we're not releasing. The functional tests were confirmed with Cobham's RCC 1.3, release candidate 1. And we're trying to keep up with the head of RTEMS here and there because we plan on going towards the RTEMS 5 release, the next major release, and we want to get up on top of the Cobham release tools as soon as that's readily and available. So that's our target goal for flying. And I guess we need to meet with the Cobham representative sometime today. So if you are here, I think Gail and others would like to meet with you. Let's see. So the RTEMS team, we gave some feedback. We found 3 RTEMS-related issues with the RTL. One was a small memory leak. After you load and unload, you can see a small leak. I think it was around 20 bytes, and we fed that back. Another one that caught us actually a couple times in testing is that you can get into an infinite loop with DL open, and if you get an external reference. And so that was not wonderful. But we found that out, and we could reproduce it and gave them a test to reproduce it. The other one is that you can actually unload a module with current dependencies, and again, that's a little scary for us. And so we fed that back to those guys. So we've got at least 3 items out there that we found from our additional RTEMS testing that should really help out. And basically, we want to make this get back into RTEMS before the next release so that everyone can use the RTL with a lot more confidence. But even so, it's been great. So functionally, the OSAL is complete. There's no API changes that we've come across needing to do. We're working on testing different tool chains and platforms, and our real goal here is to get it for our flight customer, but we want to get it out to the CFS and RTEMS communities. And so it's cleared in internal view, and we've been having lots of discussions with Dave McComas and the CFS folks at Goddard, just how does one get an OSAL out if you've developed it commercially, and what does that mean? And we're working through it, but we have a clear intention of getting out there. And if folks have suggestions on the mechanism, we're all ears. Yeah, I don't know about thumb drives. Yeah. Anyway, so we're working on the release date. Still working on the mechanism and the logistics, but it's coming. That's our intent, and that's our customer's intent. So we're not trying to keep it in the back. So with that, I definitely want to say thanks to LASP, our customer, for this flight. We've got the opportunity to do a lot of really cool work, and this is a chance for some really cool stuff to actually get out and feedback to the communities who provided such excellent code base to work with for RTEMS and CFS. And we definitely want to say thanks to Alan, who started down the RTEMS trail on OSALs, and we hope that this can be a useful tool in the toolbox. So that's it. Any questions? Yeah, I knew that would happen, right? You know, not long after lunch. Give them about 30 minutes after lunch. Alrighty. Thank y'all.
Well, thank you. Thank you, Alan.